Okay, so we've been talking about some components of the time series data and talked about the trend component, which accounts for long-term trend, cyclical component, which usually deals with 2 to 8 years length repeating cycle, right? So in business and economics analysis, we usually talk about the political business cycle, okay, which coincides with presidential election, right? So in that case, the length would be 4 to 8 years, right? So that's a typical form of cyclical component. And then we also talked about seasonal component. Okay? So seasonal component, we're talking about short-term regular wave-like patterns. So pretty much the same format as the cyclical component, but the length of the cycle is much shorter, right? So length of the cycle is within a year, okay? Typically quarterly fluctuation, right? So that, a lot of businesses, especially the merchandise retail businesses, have this seasonal component, very strong seasonal component. Okay. So the only remaining component here in the time series after the trend, cyclical, and seasonal component is what's still unexplained, is the irregular component. Irregular component is, it says noise in the time series. What we mean by noise is it's meaningless, but it's more accurately what we call random. Random movement in the data, random fluctuation in the data. Okay? I told you about the concept of random in statistics previously. You still remember? What do we mean by random when we say randomness in statistics? What do you mean by that? Huh? What? We cannot see any pattern. Okay. Yeah. What? I can't hear anything. Unexplained. Okay, deviation. Right. Yeah. Simply, randomness in statistics means we don't know. We don't know what's causing. So it is unexplained, right? There is no way we can explain, right? So out of the fluctuation or the changes in the variable, whatever variable you're talking about, let's say sales, okay? We figured out that long-term trend, and we can actually remove the long-term trend. I'll show you how to do that, okay? From the actual data series, okay? And we can figure out the cyclical component, right? How much of this fluctuation has to do with the cycle or business cycle or cyclical component, right? And we can actually remove that from actual series, okay? And we can also figure out the seasonal pattern, okay? And we can filter that out of the series, okay? And yet there will be some fluctuation or movements in the data, and now we have no explanation. We don't know what's causing, right? That's what we mean by randomness. Okay? So, well, there may be some pattern, right? But we may not be able to observe it. We're not observing it somehow, right? What we consider random variation, right? And you say, well, there is no pattern. This is a random variation, but there may be some pattern somewhere in there, right? but we just don't see it, right? We just don't know how to filter that out, right? So that's what we mean by random variation or irregular component. Okay? All right, so it is unpredictable residual fluctuation, okay? And well, what causes this random variation? Again, we don't know. This is our guess, right? It may be some natural fluctuation, right? Accidents or unusual events, right? Something that is irregular, right? It doesn't happen often. It doesn't happen regularly, right? But it's just coincidence. Something happens, right? So that's what we mean by irregular. So after we filter out the trend, cyclical, and seasonal components, whatever variation that's remaining still in the series is considered irregular component or error. Okay? Okay. All right, so we've had some introduction to the time series, okay? And let's talk about actual techniques of analyzing this time series data. Okay? First thing we're going to talk about is moving averages. Moving average seems pretty simple. Once you understand, you will think that, hey, that's nothing, right? That's really primitive idea, right? It's not even a technique. Okay? But moving average plays a very important part in the analysis of time series. Okay? Even when you go to a little bit higher econometrics class, right? You will still have to deal with moving average. It's called ARIMA, autoregressive integrative moving average. Okay? So you will keep seeing this moving averages in the econometrics. Okay? All right, smoothing means we are trying to smooth out the variation. So when you have this actual fluctuation like this, right? Many times it's hard to see the story. Right? What's the story here, right? Okay, we have y, t, and time here, right? And suppose you are interested in investing in a company, right? And you examine the past history of this company's stock price or sales or cost, whatever, right? And you see this kind of chart or graph, okay? Then it's hard to see immediately what's going on with this company, right? So smoothing means we are trying to smooth out these peaks and valleys, okay? Peaks and valleys, okay? So what if we kind of, smooth out, cut off all those peaks and valleys, okay? And then we can see what's going on, especially in the long term, from the long-term perspective, right? What's going on with this company, right? That's the idea of smoothing. Okay? So usually we try to, when you're interested in long-term trend or intermediate-term cyclical movement, okay, we tend to use this moving averages. Okay? And this is averages of consecutive time series values for a chosen period of length. Okay? It could be 3-period moving average, 5-period moving average, or 7-period moving average. Okay? We usually write MA, MA3, MA5, MA7, whatever, right? Why all odd numbers? Can't we use even numbers for the length of moving average? We can, if you want, right? But there is a little bit of practical difficulty. Okay? So we have to do one more step in case you want to do the, say, 4-period moving average or 8-period moving average. But it is possible. You can do that. I'll show you. Okay. All right. It says longer the air, the smoother the curve, but you lose some observation in the beginning and end. Yeah. When we actually look at the series and learn how to do that, how to create these moving averages, you will understand better. So let me go on. Okay. So let's say we're thinking about 5-year moving average. Okay. 5-year moving or 5-point moving average. Okay. Then what you're going to do is simply you add up first 5 numbers and divide by 5. Right. So that's an average. 5-point average. Okay. For the second average, for the next period, next observation, you will start with the second observation. Instead of Y1, you're going to start from Y2, okay, and goes up to Y6 instead of Y5, and divide by 5. So this is another average. Okay. So it's simply average, but these averages are moving. Right. For example, let's say you have actual sales data here, okay? 11-year records of the sales data. Okay? So when you create a chart or scattergram with this sales, you will see this kind of movement. Okay? So that's actual series, actual sales data. If you want to see some intermediate movement, right, then you can create some moving average. Let's say you're interested in creating 5-year moving average. Okay? Then the first number, first 5-year moving average, will be simply 23 plus 40 plus 25 plus 27 plus 32 divided by 5, right, which comes out to be 29.4. Okay? And that will be placed for the third year, year number 3, because if you choose 5 years, then the center will be at the third year, year 3, right? So you will just put that number for the third year. Okay? Then you will calculate another 5-year moving average, starting from 40 up to 48, and divide by 5, and it comes out to be 34.4. And that will be placed with the 4th year, or year number 4, right? Because year number 4 is now at the center of these 5 numbers. Okay? So that's all you need to do, right? You keep just doing that, calculating averages, but these averages are moving, right? That's the idea of moving average. Okay? And so once you calculate that, and if you draw the chart, right? This blue graph, blue line was actual time series, actual sales. Okay? But once you calculate the 5-period moving average, that will appear like this red curve, right? Because this first number here, this was 39 something, right? That was the average of this 1, 2, 3, 4, 5 numbers, right? And the second number, it was what? The first number was 29.4. First number was 34.4, right? So it's slightly higher, right? And that's the average of this, right? These 5 points, right? That's the average, right? So obviously, you will see a lot less movement or a lot less fluctuation, right? And a lot smoother curve, right? That's the idea of smoothing. Okay? Well, what happened to the first period and second period? Why don't we have moving averages for the first period and second period? You know why. Because in order to calculate the first period moving average, you need what? 2 previous years or prior to the first year, which we don't have, right? So you cannot calculate moving average for the first year. In order to calculate the moving average for the second year, right, you need just one more year, 1 year prior to the year 1, or year 0, right? But we don't have the actual sales data for the previous year, right? So that's why we are losing some observations, right, in the beginning of the series. If you go to the end, the same thing happens, right? If you want to calculate the 5-year moving average for the 10th year, year number 10, right, then you're going to add 37, 37, 50, 40, and one more year. You need one more year, right? But since we don't have it, there's no way we can calculate moving average 5-year moving average for year 10, right? And so on, right? So when you calculate the moving averages, you lose some observations in the beginning and the end of the series, right? Well, the longer the term you use, let's say you are interested in 7-year moving average, right? Then you're going to lose even more observations, right? So if you want to calculate the 7-year moving average for the year 3, right? Then you need what? You need one more observation here and one more observation here. Well, you actually, yeah, 7, right? So if you want to calculate the 7-year moving average for year 3, right? So you have 5 here, and you can use year 6, but you need one more observation here, right? So you're going to lose first 3 observations, right? You cannot calculate the 7-year moving average for the first 3 years, right? And then at the end also, last 3 years, right? You will not be able to calculate the 7-year moving average, right? That's what this statement means. The longer the L, the smoother the curve, but loses more observation in the beginning and the end. Okay? All right? If you want to use Excel, there is actually a data analysis tool for moving average. Okay? But I do not recommend you to use this tool. Okay? Because first of all, it's a very simple idea. So you can create your own formula, right, for moving average easily in the spreadsheet, right? So you don't have to use this tool, right? Secondly, this has some problem, okay? If you use this tool, then it messes up the location of the data, okay? Let me show you what I'm talking about here. All right, so I believe I copied the actual data, yeah, from the textbook, the one you just saw from the PowerPoint, right? Actual data here, right? So this is the actual spreadsheet, right? So in order to create moving average 3, what do? You're going to start from here, right? Because if you want to create the 3-peer moving average, then you're going to calculate the average of these 3, right? So you can simply say equals average and highlight these 3 numbers, right? And that's it, right? And then you can just simply copy the whole thing, right? But what about this? The last observation, right? You have to be careful because it says average B11 through 13, but at B13 it is 0. There's no observation, right? So this is actually average of these 2 observations, right? So you cannot calculate it, right? So this is simply the 3-year moving average, right? Pretty simple, right? You don't have to use you don't need any tool. If you want to calculate MA5, then you're going to start from here, right? And you simply type average, okay? And, okay. All right? And then you can simply just copy the formula all the way down here, right? That's it, right? Unfortunately, in Excel, you have to spell out average. You cannot use the short term like ABG, and that makes okay. Moving average. All right. So you can highlight if you want. Include the label here, and just click the label here. Okay. And this is the term, right? Do you want 3 period, 5 period, or 7 period, right? So let's say 5 period moving average, right? And then here, this is the funny thing. 출력, where do you want your output, right? So if you want moving average 5, normally you would think, okay, well I'm going to lose first 2 observations, right? So it should start from here, right? And guess what happens if you do that, right? Okay, right? It starts from way down here, right? So what it does is, instead of putting this first number at the center, right? It's putting the number way at the end, right? So maybe you figure out then, okay, maybe I should put it right here, right? Okay, so instead of going like this, let's just erase the whole thing. Okay, go to data. Okay, and how about if we put here, right? Then that should work, right? 2, 3. Right? Looks like, no, that still doesn't work, right? Because this 29.4 is the average of first 5 numbers, so it should start from here, right? So I don't know what Excel is thinking, and so you might want to, if you want it artificially, maybe you think, well, perhaps we should include another row here and just start from here, right? Then you're going to get this 29.4 here, right? So you can maybe make it artificially correct, right? Then you have another problem. When you create chart, right, it still doesn't work, right? So my recommendation is do not use this tool, right? Because it's pretty simple, right? You just simply create your own formula. Okay. And you can simply very easily create all those numbers, right? MA3, 5, 7, right? Okay. Any question about this moving average? I'm sure you can easily do that, right? And just for the fun of it, let's do this. Let's do it later. Okay? Okay, let's go on to the next topic today. Next topic is exponential smoothing. This is still smoothing method, but it's a slightly more sophisticated. Okay? And the formula for this is this, right? So here in this formula, EI is basically a predicted value for period 1, period I, right? Each period, right? And you calculate it by weighting the current observation and previous expected value, right? So W and 1 minus W are weights. So basically, EI, exponentially smoothed value, is simply moving. It's a weighted average. You use a weight to calculate average, okay? And between current observation and your previous prediction. Okay? So if you have okay. Time here and yt here, so time goes maybe 1, 0, 1, 2, 3, 4, whatever. Or it could be 1980, 1981, whatever, right? And your actual series, okay, your time series values, right? 1, 2, 3, 4, right? And then we can think about ET or EI, let's say I, to make it consistent. Okay? Expected or exponentially smoothed value for the second period will be W times YI plus 1 minus W times your previous prediction, right? So this is going to use this one and this one, right? I'm sorry. I'm confusing you, sorry. This one. So let's say E2 is W times Y2 plus 1 minus W times E1, right? That's what we're talking about, right? Okay. Let me change it to 1, 2, 3, 4. Sometimes I try to make it consistent with your textbook. It causes some trouble, right? Anyway, this is correct, right? So E1, E2, E3, E4, right? And E2 is Y2. This is Y2, right? This is Y1, Y2, Y3, right? And of course, this is E1. All right? So what's the story? The story is when you calculate this predicted value or expected value, right, using exponential smoothing, you're gonna make that calculation based on your current observation and then your previous predicted value, right? The same idea, if it goes on, right? What about the next period, right? Next period, E3 will be W times Y3, current observation, plus 1 minus W E2, your previous prediction, right? That's the idea, right? Okay. The only thing special here is E1 is Y1, right? Because if you want to calculate E1, according to this formula, right, E1 should be W times Y1 plus 1 minus W times E0, right? But we do not have E0, right? So because of that, we just simply say E1 equals Y1. We just simply use that first period's actual series value as E1, right? And then start out the observation, right? So actually, the actual calculation will be this one times Y1, okay? So first predicted value here is based on this and this, right? That's the idea. That's the only thing you have to keep in mind. W, weight, or sometimes we call it smoothing coefficient, right, is always between 0 and 1. Okay? We'll see a little more about that here. Yeah. So here's an example. Using the same sales data that we used before, right? we can calculate the forecast using exponential smoothing, right? Well, the forecast for the first period is not going to be calculated because we don't have the previous period's data, right? But we're going to simply use 23 for EI, right? And so, so using this formula, right? If you look at this formula, that you'll see how it is calculated, right? So, yeah, it's based on the current period, the sales value, and the predicted value for the previous period, one period prior to the current period, right? And so on. Okay? So if you look at the graph, if you actually create the graph, you will see that these numbers are a lot smoother than actual series value, right? So again, we're talking about smoothing technique, right? But it's slightly different from the simple moving average. Yeah? The biggest difference here is this. Most recent observation is given the highest weight. Right? But better than that, let me write down one more statement. Yeah? Exponentially smoothed value depends on all previous values. All previous values. Okay? Perhaps I should have said an exponentially smoothed value depends on all previous values, right? And this is as opposed to the moving average. If you think about the simple moving average, how you calculate the simple moving average, right? Each number, each smoothed value depends on only a few numbers around itself, right? So this this 29.4 is based on 5 numbers around itself, right? Third period number, right? So you add it up, 5 numbers, divide by 5. The next this number, for example, the 5-year moving average for the 5th period, right? That's only based on these 5 numbers, right? Starting from 3, 4, 5, 6, 7, right? So previous 2 numbers are not impacting or affecting this number, right? There is no influence, okay, coming from 2 previous numbers, right? And as you go on, right, the thing is, if you think about this 5-year moving average for the year 9, right? And this is based on these last 5 numbers, right? So first 6 numbers had no influence, no effect on the determination of this 39.4, or the moving average value for the 9th year, right? However, if you use exponential smoothing technique, then all previous numbers, all previous values have influence on the current expected value, right? Let me show you how it happens. Okay? So if you think about, say, E10, for example, right? E10 is let's say, assume W is 0.2. We are using weight, of 0.2, right? then it's 0.2 times Y10, the current sales value or current time series value for the year 10, right? Plus 0.8 what? E9, right? Expected value for the previous period, right? But that expected value for previous period is say 0.8 times what? That was 0.2 times Y9 plus 0.8 times E8, right? Okay? All right? That is 0.2 times Y10 plus 0.16 Y9 plus what? 0.64 what? 0.2 times Y8 plus 0.8 times E7. Okay? That's just a couple more lines. Okay? 0.2 Y0 plus 0.16 Y9. Okay? Plus, if you multiply, it's going to be what? 5? No. What is it? 0.6 times 0.2? 128, right? 0.128 times Y8 plus what? 0.512 0.2 Y7 plus 0.8 E6, and so on. It'll go on. Right? So, as you see here, in determination of E10, right, not only Y10, but Y9 is also considered. Y8 is also considered, right? And so on, right? So all previous values, all previous numbers are affecting the determination of E10, right? So you can say, in that sense, this exponential smoothing is a better technique than simple moving average, right? Because it's considering entire history, right, of this series, right? Not only just a few numbers around itself, right? So that's the first thing you have to understand about the exponential smoothing. Okay? The second thing is this one. Most recent observation is given the highest weight. Okay? As you see here, Y10 is given 20% weight. Okay? Y9 is given 16%, right? Y8 is given about 13%, right? And so on, right? So as we go on, the older numbers are getting less and less weight. And if you think about it, that should be that way, right? It makes sense, right? Because what happened a long time ago may not be that relevant to today, right? So what happened recently should be given more important consideration, right? Or higher weight, right? That's the idea of exponential smoothing, right? All right? If you want, you can try different weight, right? You can try, say, 0.5 or 0.8 for the weight, right? And of course, you'll get slightly different numbers, right? But the fact doesn't change. The fact is every expected value or exponentially smooth value is based on all previous numbers, right? And the most recent observations get the highest weight or heaviest weight, right? That doesn't change. Another thing we have to understand here is Smaller W gives more smoothing, larger W gives less smoothing. Okay? And we can actually try. Do I have? Okay. I believe this is it. Okay. So this is actual data, Treasury bill interest rate on Treasury bill. You know what Treasury bill is, right? It's a government issued bond, right? And let's say it's a 1-year Treasury bill, right? And in 1991, it was 5.38%. In 1992, it dropped to 3.43%. Back in 2008, it went down to 1.37%, right? You know what happened in 2008, right? There was a financial disaster, right? And the economy went down, right? So in order to shore up the economy, the Federal Reserve, cut the interest rate, right? And I believe if you go on 2009, 2010, right, you will see actually even lower rates, right, and so on, right? So we have actual series here. Rate is actual series, YI, right? And I created MA3 here, 3-period moving average, okay? And you can also create exponentially smoothing, right? Exponentially smooth values using weight of 0.25, right? If you use weight of 0.25, the formula goes like that, right? That's 0.25 weight times B5, which is current period actual number, right? Current interest rate, right? Plus 1 minus W, which is 0.75, times 1 previous period expected value, right, or exponentially smooth value. So this number is based on actual series and the previous exponentially smooth value, right, and so on. You just copy the formula down here, and you got everything here, right? The last thing, well, you know that for the first period we cannot calculate E1, right? So you just simply use Y1 equals E1, or E1 equals Y1, right? We just use that for the first smooth value, right? The last period, you get 3.01 based on the formula, right? Then we're going to use this value, the last value, as the forecast for the next year, right? That's what we do when we use exponential smoothing, right? The last number, okay, will be used as the forecast value for the next year. All right? So here, I've created the graph, okay, starting from 1991 to 2008. Starting from 1991 to 2008, right? And the actual rate is the red curve, right? You see this fluctuation, right, in red curve. So I'm coming down with some cold, I guess. And when you use weight of 0.25, that's the green curve, right? And it cuts off a lot of valleys and peaks, right? So compare the red curve and the green curve. Green curve goes pretty much like here, right? So it's a very smooth, right? The most smooth curve here. If you use 0.9 as weight, right? That's the blue curve, right? And blue curve pretty much follows actual series, actual red curve, right? So the idea is if you want to see a lot of smoothing, just cut off the peaks and valleys, right? And you want to see the long-term movement, right? Then you use a small weight, something close to 0, right? Then you will see the very smooth intermediate term movement, right? This green curve, right? But if your purpose is to forecast, want to make a forecast for the next year, right? Then you have to use the weight which is close to 1. Then your forecast value will be pretty close. Look at this blue dot here and red dot here. This is actual number for 2008. And the exponentially smooth value for 2008 is here if you use 0.9 as weight, right? And you know this, you're going to use that value as the forecast for the next year, right? So that's the idea, right? Why you want to use something close to 1 as the weight, right? Because that smooth series follows actual series pretty closely, right? Okay, I think we're going to continue in the next class, right?